Here we go. Let's record. All right. Inscribed angles. Develop understanding of measure of inscribed. Everyone have a thing of notes? All right. Let's go. Move up here. Where are we moving? There I go. 2. All right. There we go. Inscribed angle. Oh, we got to move some things out of the way. All right, inscribed angle is an angle whose vertex is on the circle. So it's on the circle, it's not the center. And whose sides contain chords of the circle. So this is a perfect example. So if you remember from last week, we were talking about the central angle where you had the very center that did this. Where this angle here equaled this. Can everyone see that this angle here and this angle here are not the same? See why? Okay, so BAC is an inscribed angle. So BAC is an inscribed angle, meaning it's part of the circle where the vertex lays on the circle. BC would be the intercepted arc. Okay, so let me just clear off these things. I don't need this. Okay? We good so far? All right. So, consider an inscribed angle with one leg as the diameter. Draw a radius to the end point of the chord. Okay, so if I drew this from here to here. Okay, so this is now a central angle. Remember that all radii are congruent. So that means that this segment here, this segment here, and this segment here are all congruent in length. Agreed? We now have an isosceles triangle made with the two radii. Therefore, the base angles must be congruent. So this angle here and this angle here are congruent to each other. Congruent. So, exterior angles are equal to the sum of the remote exterior angle. Recall that the central angles equal the intercepted arcs. The intercepted arc is also twice as big. So note that the arc is twice as big as the actual angle. Okay, so if this was x, then this has to be 2x, and this would have to be 2x. So think about it. Remember when let's draw this picture right here. If I had this as a triangle, this angle here and this angle here summed together equals this angle here. So that's what we're doing. So this length is 2x if this was x. This central angle would be 2x. So if this was 100, this would then be 50. If this was 200, this would be 100, so on and so forth. Does that make sense how I just described that?
Yeah.
Destroyed it. May I move on? All right. Now consider this case of an inscribed angle with the center angle, or with the inscribed angle with the center of the circle in between the two chords. Draw a diameter, excuse me, draw a diameter from the vertex of the inscribed angle. Okay. So like this. Remember we got our center right there. Okay. Draw a radii to each endpoint of the chords. So now you know you have this, 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 and this all congruent to each other. Agreed? Because those are all radii. Call one part of the inscribed angle x. So I'll call this part up here x, and then we'll call the other part y. Okay, and then make use of the isosceles triangles formed. So I have an isosceles triangle here and one here. Agreed? So this angle and this angle are congruent. This angle is congruent, and this angle are congruent. So these angles are congruent here, these two, and these would have to be congruent because your side lengths are the same length.
Okay, so like for each isosceles triangle, the bottom one is equal to the middle one.
Okay, let's see, is there anything else written on this screen? Okay, we got plenty. All right, make use of the isosceles triangles formed by the radii and mark the base angles congruent. Use the fact that the exterior angles of the sum of the remote interior angles. So the exterior angle, so that means that this angle here, this plus this is equal to that. This plus this is equal to this as far as my exterior angle goes. Okay? Remember, central angles equal the intersected arc. So the central angle, so this angle here, this whole angle here is equal to x plus y. Okay? So notice that angle BAC is x plus y. So BAC. Oh, wait, is that right? Notice x plus y and BC. Wait a minute. That should be, this should be A here. Sorry about that. A is right here. Let me erase that right there. So then you can see that angle BAC is x plus y, and arc length BC is 2x plus 2y, or 2 times the quantity x plus y. So the intercepted arc is twice as big as the inscribed angle opposite of it, and the reason is it all works with the isosceles triangles and the exterior angles of those. I feel like somebody walked in. I didn't mark them here. Don's here. Mateo's not. Emma's not. Oh, okay, we got it. Very good. Life good? Life happy?
Oh, yeah.
No?
We're doing math at 10 o'clock in the morning.
Yeah!
Having a great day. Actually,
You guys are all quiet at 10 in the morning. I request having this as a third period class. All right. Oh, there's something right there. All right, theorem 9.7. The measure of an inscribed angle is half the measure of its intercepted arc. For example, if this was a 30-degree angle right here, this was 30 degrees here, then this is double that. And vice versa. Can I move on? All right, find angle G. Got it? How big is that? 45. Find arc length TV. 76 is double. Done. That's all we got to do. Pretty much a walk in the park. Now we're on the back side. Let's see what the back side has. Oh, the back side's much tougher. Just Josh. Alright. Alright, so find measure of AD. So that's 70. And the other one, this one here is 50. Okay.
Oh, that clock is that not the daylight savings? That's why I said it was that clock.
It's on Arizona time right now.
Oh yeah, because Arizona doesn't do daylight.
What's the other state that doesn't do it?
I think Indiana.
What if that was Arizona time? 2 hours back.
Dude, how
Arizona's an hour behind us now. But at the same time as this one, we fall back. I just like to know what time it is in Arizona. Alright. So, what do we know? So, I will label this as how big? How big?
You gotta see angles.
Wait, how do you
How big is that angle?
104.
104, right?
is that just 50?
How big would this angle then be? 52. So we have the same intercepted arc that we know. So I bet you there's a theorem that's coming up that deals with if you have an inscribed angle that opens up to the same intercepted arc, then they have to be congruent to each other. So I would probably say it's safe to say that this segment and this segment are congruent. And then you could probably be safe to say that, my highlighter doesn't want to come up, that this distance here and this distance here are the same. Okay? So there's all kinds of goods. Then all of a sudden that refers to that triangle on top and the triangle on bottom are congruent to each other. So if they're congruent to each other, then you could go through a whole lot more stuff saying, I know this angle and that angle are congruent because CPCGC, or they are vertical angles. Obviously that. This is congruent to this down here. This part right here is congruent to this part here. This right here is congruent to this right here. There's all kinds of good stuff. And then other things that we know. I know this is the same as this. Why is that? Has to do with the identical chord, same size chords at the same size angle. So there's all kinds of fun stuff. And then I guess you could say, oh, well, this angle and this angle, I'll make a curve. That angle and that angle are the same because they're vertical angles. There's just a lot you can label on that. All right, consider a circle with multiple inscribed angles. We got it. Are there any congruent angles? How do you know?
Vertical.
So this angle is congruent to this angle because it opens up to this here. Agreed? All right, what else can we do? We can go this angle here and this angle here because it opens up to this, right? And then obviously our vertical angles do need to take place. We have this is congruent to this because of vertical angles. And then this over here and this over here are congruent because of vertical angles.
Oh, you could say the arc outside of the vertical angles.
What?
Oh.
Because you're wrong.
Well, I can't say that this arc is equal to this arc because these chords are different in length. That's about all we can really jumper. Yo.
C to B is
C to B, C to B, C to B, and then what?
A to B.
C, B, A, D.
No, that's not congruent. They're similar.
No, but I think,
AD.
maybe let's stick with that right now, but I like where you're thinking on that. All right, theorem 9.8.
Whoa. I don't like my language.
Whoa, hey, what? Get up here, move over. Down. All right, theorem 9.8. If two inscribed angles of a circle intercept at the same arc, then the angles are congruent, and that's what we just said. So if you had two inscribed angles of a circle intercept the same arc, then the angles are congruent. You guys want to know where this kind of math would be used out in, other than this classroom?
YMCA.
This would be YMCA as well, yes. This would be used to measure the distance between planets.
Whoa.
Wow.
Yeah, I'm telling you.
Yeah, I love that.
but it's kind of far-reaching, but it's there. It's there. And I don't want to go through the proof and show you why it works, but it's pretty cool. So next time you want to know how far that planet is from that planet,
How far
because
is
people
Jupiter
did
from
geometry. Okay, measure of angle A. So yeah, it's got to be 72 because it opens up to this arc down here, and this arc. That's same. That's 72. Sweet. And then given. Shh, too much talking. Shh, too much talking. BC is 150.
Yeah.
AC is congruent to BC. Find angle C.
It's gotta be half.
Okay, well that's got to be 150 over there, right? Those are the same. Oh, they open up to the same arcs. So that's 300. So that's got to be 60.
30.
So that's got to be 30.
Nice.
And that has to be 60 as well, right?
Okay, listen. I
Listen.
take my time.
Oh yeah. That makes sense.
I'm right in the end. Because I have to add up the 360, Devin. It's a circle.
That's it.
No. Sam. What?
I have no idea.
Woo! Got an email.
You.
Are we done?
Can we leave now?
Yeah, we are done.
Dude! We have 34 minutes to do homework.
Oh, I'm so down. Let's go. I left my homework.
Angle of what? Hush, 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 hush. Angle of what?
The angle that goes to the arc, maybe, wouldn't that be 30?
Right here?
Yeah.
No, because it's the central angle. Central angle. Alright.
Can I listen to your music?
So, homework 9-4. Lights on.